Hello, everyone. Thank you so much for having me. I'm going to bring you a little bit into my world. About once a week, I have a photo like this of my door with food in front of it that shows me that I got some food delivery. This happens because often I forget that I need to eat, and every day I decide, oh my God, I need food. A lot has changed about food delivery over time. It's not new that we are able to order online. In the 90s, you actually were able to order from Pizza Hut from something called PizzaNet in Santa Cruz. Ordering on the phone isn't new. We actually had, as early as the 1920s, Chinese food restaurants in the West Coast allowed you to place a call and get some food at any time. Even just the concept of food delivery isn't new. We were able to, in the 1880s, we found out that there's some Italian royals that got some pizzas delivered to them. But what has changed is the process. Long gone are the days where I have to talk to a human. I go on my phone, I place an order for some sushi. My address and payment information are all already in the app. And when I inevitably get impatient because I definitely ordered food way past when I was hungry, I can go in and see exactly where the driver is, send them texts. I live in Atlanta, and did you know that there's 71 streets in Atlanta that have the word Peachtree in them? And I don't actually have to let them know which one I live on. The process of getting the food to you generally looks like this, no matter which app or process that you're using. You place an order, it's received by the restaurant, it gets prepared, either their driver or a third-party driver picks it up and brings it to you. DoorDash estimates that 77% of US customers get food delivery at least once a month. Can I get a show of hands in the room who has ordered food delivered? Yeah, I would say that's about 77%. I even got food delivered today because I wanted something in my room. So 31% of people get them delivered twice a week. So there's a lot of us. And it's not just because you're lazy. There's a lot of reasons why we get food delivery. Sometimes you have an unexpected guest. Other times, I was in New York and I got sick, so I wanted soup. But because I was in New York, I was like, I have to get soup dumplings. So I got some soup dumplings delivered to the hotel I was staying at that didn't have their own food services. There's a lot of reasons why food delivery has changed, and it meets us where we're at. During the pandemic, they introduced contactless delivery. So literally, driver could place it at the foot of your door, and you could go pick it up and not have to interact because of COVID. When I think about delivery, I also think about software delivery and the software delivery lifecycle. I think all of us have seen some version of this diagram at one time or the other, or you have seen it more like this, where we talk about ideating, analyzing, designing, developing, testing, deploying, and maintaining our software. You might have even seen this model, which is much newer. It's called the Revolution model. It was created by Emily Freeman. It's on GitHub. But it talks about how the software delivery lifecycle has changed a lot from when it was first introduced. It introduces concentric circles with different versions of operation, deployment, automating, but also with intersecting spokes of observability, security, and others. Whichever way you look at the software delivery lifecycle, generally, for all of us, we are developing our software, we're building it, we're testing it, we're deploying it, and we're operating it. But we also need to observe it. The concept of adding more observability to your life cycles is known as shift left. Just to set the stage so we all know what we're talking about, when I talk about shift left, it's the approach to testing and systems where you introduce traditional observability that we have in production much earlier into our life cycles. So we can add that observability into our tests and GA environments. There's a lot of reasons that there's a lack of testing, a lack of visibility in the software delivery lifecycle. It makes it very hard to debug when failures and regressions happen. The complexity that we've seen as our systems have built and we've introduced things like serverless means that the complexity adds to slow release velocity. With having to have more complex systems, our CI and CD costs only go up over time as our systems get more complex. And also, the developer experience can get pretty difficult. If you have a lack of visibility in the SDLC, your developers aren't able to do their best work. So you might have seen a chart like this that talks about the cost of finding bugs in your SDLC, and that it is over 30 times higher to fix bugs the cost of fixing bugs is higher in production than it is at the design and coding stages. But if you aren't exactly sure if you really need that much additional visibility into your pipelines, if you've said things like, oh, that pipeline is always broken, or I feel like it's really slow, our runners just have a very long queue time, or as a developer, that's not my problem, that's a CI problem, not my code's problem. All of these mean that you are having a feeling that there's something that's wrong with your pipelines, but you don't really have visibility into knowing exactly what's going on. So how do we fix this? What does shifting left actually look like? Part of this is tooling consolidation and automation. As our products and organizations have grown, we start to see some tooling sprawl. Some of this is very natural as you have acquisitions into your organization and have different programs that you're using, different testing environments, different programming languages. But others make it difficult for new people to join your organization. It's not just when you have different CI/CD providers, but when you think about your test suites, your source code managers, your IDEs, this can get pretty difficult to have developer enablement and education. Shifting left also looks like increasing that developer experience and productivity. We want to make sure that the tools that our developers use are ones that they really enjoy. As an observability company, we really want to make sure both our developers, internally and externally, are able to have an ease of use for the platforms that they use. We want to unlock the developer productivity by giving the platform engineers the right tools and the developers an ability to self-service themselves when they need more observability or gain insight into their pipelines. This definitely digs into the code and release quality. When we talk about shipping faster, we want to also ship with confidence. We want to know that the code that we're putting out there is high value, it's high quality, secure, and provides a great experience for our end customers. Overwhelmingly, we want to make sure that we get to production in the shortest period of time, but also once things land there, they are okay. And from a DevOps and platform engineering perspective, more information needs to come to us as we scale. We want to measure what's going on with our pipelines as they go along because of the additional complexity of our deployment and development workflows. So we need to gain more insight and clarity at what's happening as this complexity grows. And I'll dig into these more as I go along the presentation. But first of all, let me give you a case study into Datadog and why we've built what I'm going to tell you about. If you haven't heard of us, Datadog is a unified observability and security platform that provides full visibility into each layer of your environment at a glance. We were having difficulty into gaining more insight into our software delivery lifecycle, and that's part of why we built the products that we did and shared them with our customers. The challenges that we were having was that the SDLC was a black box. We had some metrics to measure the output of that black box, but it was very hard to improve it without the visibility. We wanted our internal developer teams to be able to improve their platform stability while supporting the velocity and experience of the engineering teams. One of the challenges was tooling sprawl, like I've already explained. We had multiple CI providers. We had people coming in through acquisitions and different testing languages. We became very reactive to development issues. We were firefighting and troubleshooting when issues came up, and it became very difficult for anyone to understand what was going on in the system, which meant that it was hard for people to onboard into our systems as well. Specifically, to give an example, we had an issue with flaky tests. Flaky tests are tests that both pass and fail for the same commit, and when you have flaky tests into your systems, there's a lot of loss of trust in the testing of your environments. The developers really get frustrated, and there's minimal incentive if you found the flaky test to be the one to fix it, because you might not even know why the test is flaky. Additionally, the retries for a flaky test really rack up the costs. For most of us, when a test fails, the immediate thing that we do is we click retry, which totally makes sense. We all do it. But if we think about it, when we have a test that fails about once a week, and we retry it for about 5 minutes, that adds up to 4 hours a year. So how many of your tests are you retrying? And is it just once a week? That number goes up incrementally. Which leads to a lot of collateral damage. The developers will inherit other developers' flaky tests with minimal path to remediation. So some of what we did, the solution that we had was to increase the developer productivity by increasing our single pane of glass. We already had visibility into our systems with our application performance monitoring, so extending that earlier into our software during our testing and pipelines and job stages to have that aggregated visibility all in one place. We also made it that we provided an owner for each of our systems and reached out to that owner when there was a problem with their particular pipelines to reduce the alert fatigue that impacted all of our teams. Instead of every team reacting, just the team that's responsible would. So there's also not duplication of effort. By analyzing this more, we were able to identify high leverage problem areas and found which are the most problematic pipelines and jobs and analyzed how to fix them. Specifically for our flaky tests, we triaged and prioritized them. Which should we prioritize fixing first? We added flaky test detection to all of our major repos and reported the flaky tests to the owners. And when we couldn't find an owner, we disabled and quarantined those tests, meaning that they didn't run in testing. Maybe they ran in QA. We were able to distinguish by running the tests many, many times which ones were true failures and which ones were flakes, and became more data-driven instead of relying on the tribal knowledge of like, that test is usually flaky. We also built a culture of accountability. By being able to tie the flakiness back to specific commits and to specific developers, we were able to alert on a flakiness to a developer, and that developer would know how to fix their own systems and post weekly reports of flaky tests to Slack. Going back to the SDLC, we were able to add different products at different stages to gain more insight into what's going on. At the code stage, we had static analysis. At the build stage, pipeline visibility. At the testing stage, the intelligent test runner and test visibility. And I'll dig into each of these as I go on. So, where did we get started? If you use Datadog, you might have seen this before. This is our service catalog. It provides a consolidated view of all of our applications containing ownership metadata, performance insights, analysis, cost allocation, and much more. It shows you things like, for each service, what team's responsible, who's on call, what's their Slack channel, what telemetry do they have. So when you're curious about what's going on with a team, you can go in and click on each one, and all of their data is in one place. We added a tab to the software, to the service catalog about delivery, so that we could add this shift-left observability to the broader picture of the existing platform. You're able to do things like filter by environments, by team, but also see information about associated pipelines, build success rates, last executions, and more. Feeding into tooling and consolidation and automation, we wanted to make sure that we were able to use things like the service catalog all in one place. So we built integrations to each of the different CI/CD providers and had it all in the service catalog, in the same pipelines phase. So even if you were using different testing instrumentation and different languages, you had reduced context switching since all the information was in the same place no matter what team you were on. The continuous integration pipeline visibility is where we were able to get some of that view. It provided a pipeline-first view into our CI health by displaying important metrics and results from our pipelines. It helped us troubleshoot pipeline failures and address performance bottlenecks and track CI performance and reliability over time. Each of these were dashboards that we built out of the box, but you could then customize for what your team needed, showing you things like total executions, total failures, build durations, and what time is spent per stage in your platforms. So if you knew that you had a lot of time spent in deployment, maybe you wanted to dig into that and find out what is happening there. Similarly, the pipelines dashboard gave you a 10,000-foot view into what's going on into all of your pipelines. It was a starting point for our investigations and helped us quickly identify the most problematic areas of our CI and convince stakeholders with these dashboards so people can look at the dashboard instead of asking the platform teams. You're also able to have long retention rates so you can see things like month to month, quarter to quarter, and year to year trends. You can click into each pipeline and look at the flame graph visualization, just like a trace, to see which test is running sequentially or parallel, and where is the most time being spent per pipeline. This led into the developer experience because developers are at the forefront of what we do. We want to serve the needs of the platform engineers and also enable our development teams to do their best work. By having developer-oriented dashboards and views, we're able to show them things like their commits, their branches, their repositories, but also the tests that they're running, and more information about aggregated data across their CI pipelines, so that they can identify and triage things like the flaky tests and self-service and introduce best practices. Part of that is the CI test visibility. It provides a test-first view into our CI health by displaying important metrics and results from the tests, so it can help you investigate performance problems and test failures that concern your teams. This provides a flame graph view that's like a trace, so you can see am I spending the most time in a particular test. It shows you each call, which is really helpful, especially if you have calls that go out to other systems like networking or to databases. Generally, tests tend to be the longest running parts of your CI pipelines. Testing is a good thing, though. We want to incentivize people to write more tests, so that they can write good tests. By adding more visibility, it meant that they can understand when a test failed. They could actually find out where the failure happened instead of having to recreate the environment from scratch. This goes hand in hand with our flaky test management. A big part of observability around testing is helping development teams identify and triage the flaky tests. So we would run tests often, see which ones are flaky, and showcase them, highlight them, post them to Slack. By seeing exactly which tests have been flaking for the past 30 minutes, you can then work on those tests and reduce the amount of them over time. Known flaky tests would show up, and when we introduced this into our teams, we were able to reduce the number of flaky tests that we had from 150 to 5, which reduced that number by 84%. It also helped that the team's total testing time reduced because they were optimizing slow tests by spending less time on tests that are flaky. Expanding this developer view is the My Commits, which show you your tests, but also your executions, so you can see which tests were impacted by which commits. And you can then dig in and get more information into what happened when that commit happened and dig into what's going on. This helps your code and release quality. We want to catch errors in the vulnerabilities of our deployments. We want to increase the speed and stability of our pipelines and tests, and add more information and add workflows based on different signals. One thing that helped us out a lot that we created is the Intelligent Test Runner, and I really like this one, so forgive me if I'm really excited about it. But the Intelligent Test Runner is Datadog's test analysis solution. It automatically selects and runs only the relevant tests for a given commit based on the code that's being changed, which helps us increase our developer feedback loops, accelerate our software delivery because we have fewer broken pipelines because fewer pipelines are running, which also decreases the time and cost spent in our CI. The way that it works is it looks at all of your testing coverage against your code paths and looks at which tests are impacted by which code and cross-references the coverage with what's impacted by a new change. We use this information to run a selection of relevant impacted tests, omitting the ones unaffected by your code change, and overall reducing the testing duration. This means that there is immediate cost reduction because you're not running as many tests as you could be. But it also means that you're merging and deploying faster. We have faster and more stable software delivery because fewer tests are running, and you can also reduce the tests that are flaky because they're not impacted by your commit, which increases those feedback loops. For one of our demo environments, we were able to see that we had saved over 268 days of testing by introducing the Intelligent Test Runner. The reason is, without those tests running, we're completely able to count how many times they would have otherwise ran and put them together, and that's how we add up to that number. As our test suite and test coverage grows, taking more time and resources to run each test can be very complicated, so this definitely incentivizes our developers to write more tests for the code that they're working on, knowing that only that will run when they're running their tests. Going back to the service catalog, another thing that we added was code violations. This is powered by a static analysis tool and shows you things like what warnings from the new code that you're adding. And when you can dig into it more, you can see for a particular service, okay, here is the trace for each execution and spot areas that might be causing them to fail. If you haven't heard of static analysis or code analysis, it's a tool that runs in our CI and analyzes our code for quality and security issues so our engineers can have consistent and predictable feedback when they're pushing new changes. What it does is it goes through your code and looks for different security errors or different insights that you might have added so that you can see when a problem has popped up. For example, here is a specific results that mentions a potential SQL injection. So you can have a library with all of the types of problem code and then compare your code against that in the static analysis tool. We're also able to bring these signals closer to the developers by integrating into the IDE, so while they're writing the code, before it even goes into the pipelines, it can let them know that the code might not match the particular programming best practices. Going back to measuring and accelerating, we want to collect our data not only for troubleshooting, but to also do proactive maintenance and improvement. We want to identify what their baseline is and set KPIs and goals to improve our software delivery and provide those results across the organization. For different measures, we can think of the DORA metrics from the State of DevOps reports. If you haven't heard of these metrics, some of them are deployment frequency, which is how frequently your changes are pushed to production, a change lead time, which is how long it takes to go from a commit to deployed, a change failure rate, which is how frequently a deployment introduces a failure that requires immediate intervention, and the failed deployment recovery time, which shows you how long does it take to recover from a failed deployment. By having these DORA metrics all in one place, you can see them across your different teams and see what the improvements are as you're working on getting your deployment frequency to be higher or your change lead time to be lower. We asked 50 different customers, how do you define something like change lead time? Or how do you define your change failure rate? And most people will give you a different answer. Some people say that the change lead time starts from the moment that a ticket gets created, or someone else will say that it's from the moment that a commit first gets pushed. You can be very flexible with your approach and define it for your organization and see the improvements as you make changes. And slice and dice this across different dimensions like teams, services, repositories, and more. Putting these in the service catalog shows us the information while we're also looking at other reliability metrics like the number of incidents per our services and our different teams. Stepping back into the State of DevOps report, last year's report asked all of the survey respondents to identify themselves over how long are their deployment frequencies, what's their change lead time, what's their change failure rate, and more. While I'm sure that most of us would want to aim for the elite performance level where you're deploying on demand, and when you have a change, it's deployed within a day, and when a change fails, you're able to recover within an hour and only 5% fails. That isn't true for most of us. Being able to measure what's going on into our systems and find out which areas can improve and why we would actually need them to improve is important. But for some of us, we might not need to aim very high in terms of our changed lead time. I've been on teams where we definitely only deployed once a week, and that was very fine for us. We were an internal platform team. But we might still also want our change failure rate to be low. So being able to measure what's going on with our reports, what's going on with our systems, and gain insights and get an overall view of what's happening is important no matter what stage and what your goals are. Changing gears a little bit, I want to tell you about one of our customers who came to Datadog specifically to gain more insight into their CI systems. This is a large multinational fast food chain, and they wanted to gain more insight and optimize and automate their CI/CD practices. They have a large engineering organization, and we're working on a range of code bases from things like digital ordering, loyalty, point-of-sale systems, and more. The challenges that they were having was limited observability. It was hindering their releases, and they were having a hard time detecting their CI performance issues before release. They also had tool sprawl, as most large organizations do. So different teams across their different organizations used different CI tools, which led to context switching and poor collaboration, which meant that they were very slow in manual investigations where you can't collaborate with other people. When there is problem areas, it's hard to know what exactly is going on, and root cause analysis took a very long time and delayed releases. The solution after using our CI visibility tool was they gained more CI observability. The company was able to automatically track their key metrics, indicating the quality of upcoming releases as they proceeded through their pipeline and testing processes. They were able to use a unified platform because it was all in one place with the service catalog, so their engineering and business stakeholders could look at dashboards and track performance of different CI tools in a singular view, which meant that they also had faster root cause analysis. Whenever a pipeline or test error propped up, they were able to pull it up, dig into that bottleneck, find out what's going on, and look at the relevant pipeline tests and attributing logs that go with that. They said that Datadog's unique CI and CD test visibility solutions brought them production-level visibility into their pre-production environments for the first time in their history. This CI tool consolidation in the unified platform meant that their over 200 committers were monitoring the CI pipelines and tests to ensure frequent and reliable releases. Here's another shout out from the State of DevOps report. It says teams with shorter code reviews have 50% better software delivery performance. And I can definitely agree with that. When you're able to spend less time trying to get your code out, it means that you're able to run more code and gain more insight into what's going on. So, to recap, shifting left can mean a lot of things for your organization, but no matter what tools you're using, we want to make sure that you're consolidating your tools to gain more insight into what's going on. It means that your teams can collaborate better, that increases their developer experience and productivity. It means that their code release quality can go up. But of course, we want to measure and know that we can accelerate our software delivery and know exactly where we need fixing. All of these are ingredients to aid your software delivery. And all of these will lead to incremental changes, but they add up to a very big, delicious dish at the end. At Datadog, while software delivery is one part of what we do, these improvements assisted our larger organization and expanded our existing observability toolkit to showcase the information for ourselves and our customers all in one place. I hope this was helpful to you, and I've convinced you to add more visibility into your services. Thank you so much for your time.